All right, I think now we're live. Hi, everyone. Hi, Shawn. Hi, Gav. Thank you very much, guys, for the time. And thanks, everybody, for connecting. We've got around 90 people or so, which is kind of like a record for the Substrate Builders Program office hour. But I'm super excited of that. So thank you very much. Today, we're going to have an AMA on XCM, right? I know that Gav and Shawn have been working a lot on this, so it's going to be super interesting to see where XCM is at and understand it a bit more. First of all, Gab is going to go through a presentation that he has. Then we're going to have Shawn as well presenting something. Then we're going to open for questions. Please do use the ask a question field that's somewhere in Crowdcast. We're going to use that as a guide because Gab has already been going over the questions of the HackMD and answering most of them. So yeah, without further ado, Gab, I'll leave it to you and take it from here. Thank you very much.
Cool, thank you. Yeah, so this is a probably not too long, but a bit of a presentation on XCM. We've actually just finished about a 2-week long coding retreat here, getting XCM into shape for the upcoming Polkadot move to parachains, trying to get some of the rough edges nicely smoothed. So this is a super quick XCM introduction for basically meant for people who aren't super familiar with it yet, but also I hope it gives some clarity over some of the design decisions that we took when designing XCM. So XCM, cross consensus messaging. It's not just cross chain. The main thing is, in addition to cross chain, is for smart contracts. So the idea is that this is something that chains can use to talk to each other, but also that chains can use to talk to smart contracts that exist on the chain, potentially also pallets, although that's not really something that we're going to support anytime soon. But and potentially it can go between different consensus systems. So the idea is that the endpoints of the XCM interlocutors, XCM talkers, are consensus systems, not necessarily just blockchains. And also it's a format. I noticed there is sometimes some confusion over XCM, XCMP. It's not like people are not always so clear as to what XCM is, what it's meant to do. It's a format. XCMP is the protocol, right? So XCMP is how different parachains on Polkadot, on Kusama, talk to each other. XCM is the format or the language that they use to talk to each other, right? And there are other ways that chains can talk to each other, not just XCMP. So if we look at this is new. This isn't something that you should expect to have seen before. But this is the stack, right? This is the stack that XCM finds itself in. So there's XCM in the middle, and you can see, like, at the very top there, this is the business logic that is going to be trying to send XCM, right? And in order to send XCM, it's going to use some XCM interface, right? And in the case of pallets, which is the use case that we've sort of designing for right now, that we're implementing right now, you use the XCM builder crate in order to send XCM, construct XCM and send XCM. And then there's like the transport protocols underneath the XCM. These are the things that we're going to actually be moving messages between consensus systems with. So there's XCMP, that's a transport protocol that moves it between parachains on Polkadot, parachains on Kusama. There's also VMP, vertical message passing. This is used to move XCM messages between the relay chain and the parachains. So like UMP would be upwards message passing. That's how parachains communicate to the relay chain. And then DMP, downwards message passing, is how the relay chain sends messages back down to parachains. And in addition to that, we've got things like bridges that will allow solo chains to talk to each other using XCM. At least eventually, that's something that's still in development. And then finally, they've got this idea of custom relays, which is basically how you send XCM messages internally within a chain. So potentially sending them down into a pallet, or more likely sending them into a smart contract. And then on the very bottom, the consensus environments that could possibly send or receive XCM messages, parachains, solar chains, and then smart contract platforms that exist within Substrate, Canvas, and Frontier, and eventually potentially other smart contract platforms that don't exist within Substrate. But that's not here quite yet. Okay, so goals of XCM, which might not be again super obvious. We want XCM to be flexible, so it's useful for like lots of use cases, not just the first use cases, not just the common use cases, but like very useful for things beyond what we sort of initially imagined. Extensible, so it can be actually, it can be moved forward over time. Like new use cases become clear, we want to be able to have a format that's going to be able to evolve and change according to what those use cases turn out to be. And general, so we're actually, this is a bit like flexible, but the idea is with general, we don't want to make any design decisions that are going to dirty things up. So we want to make a format or a language that is just as capable as handling, let's say, a fee based blockchain as something that's for handling, blockchains that want to communicate each other but don't need to communicate, don't need fee payment as being a part of it. And this kind of strife for generality means that we're not going to bake in certain functionality unless we're pretty sure that it will always be needed. And to take the example of fee payment, we know that there will be instances where we don't need to pay fees between chains. For example, if two teams have a parathread, each have a parathread. Sorry, if one team has two parathreads, then it could easily be that those parathreads never bother sending fees to each other. They don't need to because they trust each other. They're from the same team. And finally, that's suitable for on-chain, on-chain mechanisms. So this on-chain kind of, I kind of, it's quite a general term here, but basically they need to be suitable for these resource-constrained environments, potentially a smart contract where it's going to be metered, or potentially in a pallet, but where it's maybe not metered, but we're still sort of very weight conscious. We're still conscious of the performance. So it's got to be pretty high performance, low cost. So something that may possibly occur to you is like, why not just use the native transaction format, the native message format? Why not, if we're dealing with a smart contract, just call into its API, and if we're dealing with a frame-based substrate chain, why not just use the pallets dispatchables? There are a few reasons. I don't want to write off this completely. Sometimes going native is the correct way of solving a problem. XCM is meant to be general, and that means that some things are just not sensible to move on to XCM, some very niche pieces of functionality. But the reasons that we don't want to use native all the time are, well, firstly, it's going to be specific to the destination. So basically, if you can't send a hey, transfer one dot kind of message to many different destinations and expect to be able to send the same message to each of those destinations. No, you have to know each destination's, assuming that they're frame-based substrate chains, you're going to have to know the balances palette index at each destination. So you're going to have to know that they got a balances palette. You're going to have to know if it's not a balances palette, maybe it's an assets palette that they use to represent dot, which index in the assets palette they're using to represent it, which, all sorts of other bits. Secondly, it's obsoletable, which basically means your chain or your smart contract or your palette, which you're communicating with, might have upgraded itself since you last sort of knew how to talk to it, and that may change how you talk to it. It may change the indices, or it may change which palettes it happens to have, and that's that's something that you would have to track manually. Not so great. Next, it's like this idea that single transactions may not sort of be able to do just what you want to do. You have to start sort of batching them up, and there may not be sufficient functionality for batching them up in the native format. Maybe there isn't, like, you know, I mean, if there's a batch, if there's this utility palette with a batch dispatchable on, then you can kind of argue, well, I could just use that, but maybe there isn't a utility palette on the chain that you want to talk to. And it may be that the thing that you need to do is to like actually use multiple things. You may want to do an exchange of an asset before you want to deposit the asset somewhere. And finally, stuff like fee payments doesn't necessarily fit into the native dispatch system. For example, with Substrate Frame, you're kind of already assuming that that the fee's been paid by the time you get into the dispatch of a frame palette, because the fee payment is done as part of the transaction. And you say, oh, well, why not just use the transaction format? Well, of course, the transaction format isn't useful either, because the transaction format brings in this idea of signatures. And, you know, if you've got two consensus systems talking to each other, they can't sign. There is no notion of signed messages. Okay, so the initial use cases that we considered, in case you're wondering, are fee payment, but making it fee payment for the chains that actual consensus systems that want to pay fees between each other. So it's got to be optional. Remote transfer of funds and interchain transfer of funds. So remote transfer of funds is where you've got like some funds on a remote chain, you own them on your chain, you own those funds, but the funds don't have any particular there's nothing on your chain that represents those funds. It's just your chain happens to know that it has some funds available to it on some other chain, transferring those. Interchain transfer of funds is where there are actually funds on one chain and they actually want to transfer those funds onto another chain. So like actually reduce a balance on their chain in order to increase a balance on another chain. So there are two different use cases. Remote exchange, so the ability to command some sort of exchange on another chain. So have some assets on another chain and actually exchange them for some other assets. Passing other assets, not just funds, so like NFTs between chains would be good. And I'm not sure what the final one is. Let's get to that. So I want to talk a little bit about orders versus instructions. This, I think, is something that people are not always so sure about. Basically, the difference is that instructions, XCM instructions, are standalone things. They just sort of, they arrive, they get executed. There is no assumptions, no additional assumptions over the environment that they get executed in. Orders, on the other hand, have all of the assumptions that instructions do, but they also assume that there's this thing called a holding register, which is basically assets in hand, assets that haven't yet been spent, but have been removed from the chain or don't exist on the chain anymore. So an XCM message, that's always an instruction, right? You don't get orders just arriving on their own, naked, bare. They have to be sort of, there has to be some way of getting something into the holding register before before an order can be executed. But instructions that do populate the holding register will generally need to include some orders. Okay, good. The other thing I wanted to talk about that you're already aware of is teleport versus reserve-backed transferring. So these are two ways of transferring assets between chains, right? And there's often some confusion about which ones should be used. The easy answer is, for community parachains, you're always going to use reserve-backed transfer at the moment, until we get Spree, which will allow teleporting between community chains. The only option is reserve-backed transferring. Teleporting is faster and cheaper, but it does require the two endpoints to trust each other, and that's not going to be the case in general for community chains. Now, it might be that there are community chains that do set up some trust relationship, and they end up wanting to use teleport between each other. Great, fine. That's entirely up to you guys. But in general, reserve-backed transfers are going to be the ones that you're going to want to use if you're not 100 million% sure that the other chain isn't going to try sending you assets that don't really exist. So how does teleport work? Teleport is very simple. Essentially, an asset is just destroyed on the sending side, and then a notification message is sent from the sending side directly to the receiving side, mentioning that they were destroyed, so that the receiving side can create those assets. Now, it does therefore mean that the receiving side has to trust that when it gets this message from the sending side did destroy the assets. Because if it didn't, then there's going to be sort of double spending, right? There's going to be two lots of the same asset when there was only one before. That's really bad. Reserve-backed assets or reserve-backed transfers are where there is a third chain involved. And the third chain is the one that actually kind of holds the underlying asset that both of the other chains, the ones that send in the receiving chain, agree should always be held for their on-chain representation of that asset. So we can imagine, for example, State Mine on Kusama has KSM. It has what can reasonably be considered a native version of KSM, and community parachains that want to hold KSM would back it with KSM that's on State Mine. And when they want to send KSM between each other, they would use a reserve-backed transfer, which basically means though they would destroy the KSM on the sending chain, they would transfer the KSM that the sending chain held on State Mine over to the destination chain's account on State Mine. And then State Mine would then onward send a message to the destination chain mentioning, hey, you've got your sovereign account has received some KSM. You feel you should mint some KSM, some derivative KSM, some KSM on your chain to recognize that. And here's what you should do with it, right? That's kind of how reserve-backed transfers work. And the crucial thing is that both the sending and the receiving chain they don't have to trust each other, right? They don't have to trust that the receiving chain doesn't have to trust that the sending chain sort of did anything in particular, because the only message it's getting is a message from State Mine, which we will assume it does trust. Okay, now this next sort of section is new, and this is one of the things that we've been working on at the retreat, so it's in the last couple of weeks, and basically it's versioning of XCM. We've been working on version 1 of XCM, the version that's sort of up until now, up until recently was in master branch, and released was version 0. And there's a few changes. It doesn't bring in too many features. It's mostly an API change. There are one or two small changes to the underlying message format, but not very many. Features will be coming in a bit later, but it is incompatible with version 0. So version 0 is the thing that's been released at the moment. It's in v0.98, and it will be in v0.99, which is coming out imminently. But it will no longer be the latest version in v0.910. v0.910 will include v1, as the master branch does indeed at the moment. Now, when v0.910, and if you look in the master branch, you'll also see this v0 is forwards compatible with v1, which basically means messages that are written in v0 can be translated into v1. And similarly, actually, v1 is backwards compatible to v0, so messages written in v0 can be generally translated into messages written in v1 can generally be translated back into v0. At the moment, v0 is in general use over the wire. So I want to kind of show you the story of what will happen over time, so that we can move to v1 without anything going wrong too much, as long as people stay reasonably up to date, reasonably timely. Okay, so what will eventually happen is that v1 will be released, and that's going to happen quite soon when v0.910 is released, which will probably happen in the next week or so. v0 will remain in the v0.910 code base, right? So if your API uses if your chain uses the v0 API, that's fine. It will be able to continue using it. It should be source code compatible, which means when you update, you won't it'll still build, it'll still run, it'll still work just fine. With v1 released, new chains, runtimes that use the new APIs will probably, and they get to choose, but by the expectation is they will continue to use v1 over the wire. So when these runtimes send XCM messages to other chains, the XCM messages, even though they may be written using the V1 API, and they're actually sort of V1 messages, so to speak, they will be translated into V0 before they're sent over the wire. Now, this won't, of course, work for all V1 messages, but it will work for most of them. This will continue for some time. So basically, there's an upgrade period, right? There's a period where there are going to be V0 and V1 chains, and during that period, both APIs are going to be available, and the messages that are going to be sent over the wire will use the older of the two versions. Now, because V0 is or V1 is backwards compatible with V0, it means that when a chain running the V0910 or above receives one of these V0 messages, whether it's from one of the newer chains or an older chain, it can convert it into V1 and execute it. And during this time, there'll probably be a V2 that's in development. And again, this will be backwards compatible with V1. So any V1 messages coming into a V2 enabled chain will be converted. Great. So basically everything converts between everything else. Now, this isn't perfect. Some V0 messages can't make it into V1 and vice versa. For now, people during this sort of transition period, if you're using V1, you should be thinking carefully about using any new features if you're expecting these messages to go into the runtime anytime soon, or a production runtime anytime soon. Now, sometime later, and I'll say for now 4 weeks later, because I think this is a reasonable period of time, any production chains should be upgraded to V0910. Now, what this means is that you just need to use V0910 or above Polkadot API, Polkadot crates. It doesn't mean you have to change your code necessarily. The idea is that V0 is still in place for another 5 months after this, right? So you can still use the V0 APIs. So you don't have to actually manually alter your own code, but you need to get your chain up to the point where it can understand V1 messages, and that's V0910. When you are, so this will continue for 4 weeks, and for these 4 weeks, you can basically carry on using. Within these 4 weeks, you need to move to V1. Move to V0910. And finally, hey,
I'm going to Berlin.
I'm broadcasting to the world.
Okay.
Cool.
Yes,
I'll see you later.
See you soon. Yes.
Ciao, ciao. So within these 4 weeks, it's important that you actually make the upgrade so that your runtime can comprehend V1 messages, because following the 4 weeks from the V1 release, or the first Polkadot release that contains V1, we would expect V1 or chains to move over to using V1. So basically, they'll stop translating their messages that they're sending into V0, and they'll just send messages straight in V1. And that will mean that chains before 0910, or chains before the release where the V1 sort of was brought in, will no longer be able to understand those messages. That said, V1 is forwards compatible with V2, V2 is backwards compatible with V1. And the V0 API will continue to be in the code base. So your chain doesn't need to alter its code so much, it just needs to make sure it's using the latest Polkadot libraries. 6 months after V0910 was brought in, after the first release that actually contained V1, or the final version of V1 at least, was brought in, V0, the plan is to remove V0 from the code base. So basically, you've got that 6 months to upgrade to version 0910 of Polkadot, use those crates, but also to move your code over from using the V0 API to V1. So this basically means the API and the underlying the messages that are going to be pinged around on production networks will have some period of time where multiple versions of them are utilizable. But for pinging messages around the network, which is really just a cargo update, you get 4 weeks to do that before you have to have it in your runtime. For actual code changes where you're going to have to move to a different API, you get 6 months. So just to reiterate that, versioning code of conduct for the XCM Polkadot community, bump XCM, rebuild and deploy the runtime in 4 weeks after a new XCM release, update the latest XCM API at most 6 months after that's been released. And if you do those two things, you should be good. You should be able to use XCM with abandon. There is a caveat: compatibility isn't 100% between these individual versions. Of course, if new features come in, then you just can't do that. And if we remove certain functionality, then similarly, it's impossible to provide that level of compatibility indefinitely. So the sooner that you upgrade when these versions come out, generally the better. I'll add to that one thing. At the moment, when we send messages out on the wire, we always encode them with the same version. That isn't needed. That we don't need to do that. We can encode them with different versions depending on the destination. So it's perfectly possible, for example, if you know that there's a legacy chain, and it's going to use v0 for another 3 months yet because for whatever reason. You can configure your parachain to send v1 messages to most of the chains, but send v0 messages to that particular destination, knowing that it can't understand v1 messages yet. And similarly, if you know that there's a chain that's already upgraded to like v2, then you can, and your chain's capable of authoring v2 messages, you can do a similar thing where you can say, well, if it's this chain, then send a v2 message to it. And if it's sending a v2 message and you're authoring messages in v2, it means that when you're sending messages to that chain, you can use any new features of v2 that you might not otherwise be able to have used if it's v1. So, but that's future stuff, really. So I want to talk a little bit about what we have planned for XCM in the future. Some of these features are very important, I know, and they are coming. Query response and success reporting is probably the single biggest thing that we get asked for. So that's probably that's pretty much the top priority now. Query response is basically where you can send a message to a chain, query, whatever, something on it, whatever that will be. Balances of your account or whatever, and expect to get a response back. Now the response comes back as an XCM message, which means there's all sorts of question marks over, for example, how fees are paid. But that's something that we'll be managing over the next weeks when we're implementing this. Success reporting is basically a sub problem of query response, and this is kind of like a query. It's just a query that's implicit. It's like I'm sending this message, like transfer a balance or whatever, and I want to know if it was successful. Well, there will be a response. You'll be able to configure XCM to give a response back to the sending chain. Hey, your transfer was successful. But we can't really do that until we have a framework for doing query responses in the first place. Execution checkpoints. Basically, this is where you can say, I either want all of this to happen or none of this to happen. That's not something that's supported yet, but it's something that's relatively easy to do with our database checkpointing system. Fail-safe try-catch handlers. This is essentially where you can execute different XCM messages or different orders depending on what happens with previous orders. So if an order fails, then you can kind of drop out into a catch handler and do something like, send some assets back to the sending chain or record the whatever was in the holding account or whatever. This is going to be super important when you're not entirely sure if the destination chain is going to handle your message as you expect. And it means that, the terrible possibility, the nightmare possibility of the holding account or the holding register, we call it now, the contents just being dropped. It means that you can mostly avoid that possibility. Finally, safe transacting. This is stuff that's been on the cards for a few months now, but basically it's an adjunct, an addition to the transact XCM or transact order, allowing you to basically query a chain and transact or sort of dispatch a call when you're not necessarily entirely sure of or despite the possibility of the version having changed or the index having changed. And you can basically like make sure that your assumptions over the version and the index are still valid for the transaction to go through, which basically then means that you're safe against the chain upgrading, which at the moment, if you're using transact, you're not. The final thing that we're going to sort of have planned for the future is governance over the XCM standard. So we want to make sure that this is a community-owned standard once we've got the initial functionality there, and that it evolves with community needs in an open and decentralized way. So essentially, we want to set up some sort of governance mechanism over the XCM standard so that everyone can put in effort and time and try and make it as good as possible if that's what they want to do. Good. That's the end to the little introduction and an update on what we've been doing so far. There are questions from the community that I have not yet answered, but I think we're going to leave those to the end. And first we will have Shawn, who is going to talk a little bit about what he and Kian have been working on over the last couple of weeks.
Do me a favor and mute your mic when you don't have to double.
Sure. Let me just
unmute my mic.
I have to share a screen.
I can do it if not. Muted Gav already, yeah.
Can I get a confirmation that you guys can hear me in the chat?
I can hear you.
Yeah, cool.
Perfect.
Sweet. And then hopefully you can see my screen. Can you see my screen?
Yeah.
Okay, cool.
Yes.
Yeah, well, I wanted to just give a brief overview of benchmarking, but I guess, first we should talk about the retreat a little bit more. Yeah, we were spending basically 2 weeks hacking together here in Stockholm. We had some parity engineers. We had some parachain teams locally, things like Moonbeam and ASAR. Some members came here and worked with us. And we even had some parachain teams working remotely, like a call-in more. Some of the main goals we had during this XCM retreat was getting XCM V1, which Gav kind of hinted towards in his last presentation, getting some XCM unit and integration tests into Polkadot, so that you all can actually, verify that your scenarios are working. And then, of course, XCM benchmarking. I just wanted to call out, the integration and unit testing. A big thanks to Shawn from the Ecala team, who basically already wrote this on his own. And then we kind of kindly asked him to bring it over here so that you all can have the same functionality. So big thanks to him for basically writing that and making it available for everyone. But yeah, I'll give just a kind of a high-level introduction to XCM benchmarking. Again, this is something that will affect everyone here. If you want to, launch your chain in production, it's very important that you have the right benchmarking and weights so that your chain isn't attacked and XCM isn't another point of vulnerability for your chain. So a little bit of an overview. So I'll do a quick recap of weights, just make sure that you understand what I mean when I say the word weights. Hopefully most of you do already know if you're building any parachains. We're talking about the road to Polkadot, why weights are important, XCM benchmarking abstractions, some of the implementation details, and some future steps. So first, what is weight? At a very high level, weight is basically a representation of block execution time. So, all of the blockchains built with Substrate basically have a target block time. And in that time, there's only so much computation we can do. Of course, the amount of computation can vary based off of how much time you have, what kind of computers you use, what kind of networking situation you have, like a bunch of different things. But in general, weight is this abstract concept described, like how much time is available to do things. And this weight concept is probably going to be expanded in the near future. So we've been worried about time for a while now. But as we've seen with parachains, the next kind of factor of limitations we might have is this POV block. So if you're a parachain team trying to validate new blocks onto the relay chain, you'll actually have to present a POV block, and there's limits there too. So you might see that weight continues to expand to the other kinds of limits within the systems in the blockchain. And of course, if you want to learn more about weights and benchmarking, there's a 3-hour video I did with Substrate Seminar. There's a link here. You can find it with a Google search, or hopefully someone can post it into chat. Yeah. So then let's talk about first of all why weights are so important. Why benchmarking was a key part of the retreat here. Well, ultimately, it is our road to Polkadot. So like while Kusama currently does have XCM and it's happy to accept development versions of XCM, Polkadot is not about the chaos lifestyle. Like, we want to get XCM on Polkadot, so we need to make sure that we have secure security audits of XCM v1, that we have production-ready weights for the relay chain, and of course, an extensible and reusable benchmarking system for all the different parachain teams, so that you can go ahead and actually add your own weights and be part of the overall XCM and XCMP system, right? And so to get into this production state, we need to talk about the XCM benchmarking framework. And first thing I want to note is that this is something that is quite new. I'm sure it will change a lot if you followed the old benchmarking framework. We've been iterating on it based off feedback and trying to make it better and easier to use. So definitely you can expect things here to change based off of feedback that you all give to us. But from a high level, there are a few different abstractions of XCM which you can basically plug into. So first we have XCM itself. Then we have the XCM executor, which actually runs and executes the different messages. So the XCM itself is the message format. The executor actually executes the messages. Then we have XCM benchmarking. And then finally, the runtime configuration of your chain. And by the way, I'm just going to say XCM so many times, I think it's going to be like, it's going to be hard to get that word out every single time. But basically, let's start with the first XCM message format abstraction. So as Gav kind of mentioned, there's these XCMs, and then there's these orders. And when you construct the new XCM message, you're basically composing some combination of XCM and orders with all the different inputs and doing that. And so you can see here with all the different XCM calls and all the different orders, there's a bunch of different things you can expect to get. And in order for us to have a good weight system, we basically need to have a weight for each of these things. So kind of as a first step, we basically took all the different orders and XCMs and created a trait which describes, well, with every single one of these XCMs or orders, given all of its inputs, we need something to tell us what the weight is. And that trait can basically describe that. Of course, at a high level, you can implement this trait pretty much however you want. We've implemented this trait kind of in the Kusama world by basically saying everything takes some large weight, probably something that's more than any individual XCM itself. And we basically put that on chain saying, hey, if you want to do XCM, you just pay this heavy weight. But of course, when you're a production level chain, you want to optimize your weight to be both safe for your chain, but also low cost for your users, right? And so this first trait is the ultimate way you get access to add weights to your system. And then we're going to talk about the XCM executor. So again, the XCM messages alone don't really do anything, right? So you have these messages and they're just some format. The XCM executor is the one that actually listens to these XCM messages and actually executes things in your runtime based off of your configuration. And you can see here the XCM executor has a ton of configuration settings. And if you've actually tried to implement the XCM executor yourself, you would know that it's like nested upon nested upon nested configuration settings. There's like a lot of things you can do here. But what we care about for benchmarking is specifically this one configuration called the weigher. And the weigher basically plugs into the execution environment, looks at what an XCM message is, and tells us this is what the weight of it should be from a very abstract level, right? And so if we look at what this weigher does, this weigher expects this thing called a weight bounds. And a weight bounds basically takes in an XCM message and can give us either a shallow weight or a deep weight. So a shallow weight is basically the minimum amount of weight needed to be that fees need to cover to even process the message. So processing a message itself can have an overhead. And basically what we want to make sure is that the shallow weight covers any kind of base processing fees for even reading that message. And then, of course, we have a deep weight, which is any additional weight which is needed to actually execute the full message. So all of the instructions inside of an XCM message, that deep weight is the kind of the full amount. And of course, the shallow plus the deep gives the full overall message weight and the fees that would be needed for the whole system. When we take a look at this XCM executor, we can basically provide for you an implementation of weight bounds as long as you can provide for us an implementation of the XCM weight info. So again, at the high level, at XCM, we have these weights for each of the different orders and XCMs, and we want to get to this weight bounds weigher for the XCM executor. And we basically can automatically do that for you through an implementation which is kind of specific to how XCM executor works. So as long as XCM executor is in a certain version or a certain mode, we're able to automatically kind of generate for you the information that's needed given this XCM weight info. Right? So then let's take a look at the abstraction layer of the XCM benchmarking. So one of the things we've tried to do to optimize our time here is basically we were able to reuse the frame benchmarking system to be able to also kind of measure XCM benchmarking. Now, I think there are some optimizations that could be done to benchmarking of XCM if we were to add some kind of wrappers or abstractions for XCM specifically. But for now, I think it's good enough we have frame, and we'll try to show you how that works. So basically, in order to get that all working, we had to get make these like dummy palettes. So we have these dummy palettes, which basically input some of the configurations from XCM, and then sets up the runtime state and executes any of the XCMs or orders to be able to get a weight value for it. What we've provided through this retreat is basically a basic benchmarking framework that works for the balances palette or the assets palette. So that's anything that works with the fungible or fungibles trait. Now, of course, if you have your own custom currency palette, which maybe has different behaviors, then you might have to actually write your own benchmarking. But assuming that, one assumption we have for the assets palette is that all assets basically have the same weight. So it doesn't matter which asset you're touching, that as long as you're touching an asset, it should be about approximately the same. And so if your palettes have similar kinds of assumptions, and you also implement the fungibles trait, you should be able just to plug in your palette into our benchmarking code, and it should just work. And of course, you should always be able to, and you can, write your own benchmarking for your own system. So there might be a bunch of palettes or abstractions which we don't even cover in the basic scenarios here. You can, of course, write your own and implement that into your system. One thing I wanted to note when writing these benchmarking things, it was very hard to make these palettes very generic for all the ways you could configure the executor. So we try our best to basically do that. But it's likely that if you have a team, if you're a team that's doing a lot of very custom or unique, interesting ideas with XCM, which is totally possible, that you might need to extend or modify the benchmarks that we provide to you to make it work. So things like if you have very custom barriers, or you have custom mappings for which kind of users can send messages to you or how you want to process fees, we have a very base level kind of thing that works for StateMine and for West End, but we won't cover all the complex scenarios in our basic benchmarking. And maybe we can continue to extend that. So definitely let us know what kinds of features are missing, and we can go ahead and get that feedback, maybe iterate on the designs here. But if we dive a little bit deeper into the actual dummy benchmark palettes that we have here, you can see basically we just have a config trait like you would expect from any other palette. And through that, we're able to pass in all the XCM config that we have set up in our runtime. So things like the XCM config itself, like all the different parameters, things like account ID converters, things like, what is a valid destination? So I'm going to run a benchmark, and the benchmark is going to send XCM messages. You should tell us what kind of destination is actually good that we can do this test and succeed, right? So we ask for basically some information about the runtime. And sometimes we even ask things like, give me a multi-asset. Like, we're going to do a test with a multi-asset. Tell us one that your chain will consider valid. Or we might even ask things like, tell us the worst case scenario for a query on your chain. So if some XCM message comes to your chain and is querying some data, tell us what the worst case scenario is. So these are all, again, things that are extremely customizable via XCM. And when you use the palette, basically you have to kind of give us a hint. What is those worst case scenarios? But as long as you can tell us those information, we're able to go ahead and process and generate benchmarks for you. So finally, let's glue it all together, right? So when you actually run the benchmarks, you're going to get a very familiar benchmark output. One thing that's unique about this versus the palette benchmarks is we actually don't have any assumption of what kind of benchmark output you're going to have. So in the palette system, we basically make a trait based off of all the extrinsics in the palette, right? Here, we don't actually know exactly how you want to benchmark your XCM or the way that your palettes interact with your overall runtime. So we kind of leave it to you to define what that API is, right? And we will always generate for you a file that works. From there, we basically ask you to plug in these different benchmarks into this XCM weight info. Remember, this XCM weight info is that first thing that if you can provide this to us, we can generate everything else ourselves. So we have all these benchmarks or whatever you want to abstract, and you point us, okay, well, given the inputs of any XCM message, for example, there's a list of assets, tell us how we should map those assets to then look at the weights and benchmarks that you have. And unfortunately, right now, this is a little bit of a manual process. It's quite hard to generate this all in an abstract way. But what we probably can do is provide a little bit more automation in the future, which will make this generation very simple, as long as you kind of follow the basic kind of framework that we have set up in our balances and assets benchmarking. But really, actually updating this one manual step is quite easy. Basically, if you provide a new palette or a new feature to XCM, you get new benchmarks, and you have to basically add some new lines into this XCM. And one of the things we found that would help us generate this XCM very easily is actually an assets lookup table. And so something like this, where you basically say, like, oh, here are all the different assets on my chain. So I have a balances palette, I have an assets palette, and let me convert between a multi-asset ID to tell me which palette I expect to use for that asset. So for example, in this example I'm presenting here, for any multi-asset with concrete ID here, right, I'm gonna assume that that is the, the main system currency for the chain, and so I'll use the balances palette. And then for any multi-asset with an abstract ID, we're going to assume that uses the assets palette, and anything else that doesn't fit these two match statements would be unknown, and our chain wouldn't process it at all. So this is one thing we found that would make it really easy to actually generate these XCM weight info. But of course, this is totally up to you. What exactly you want to do here, or exactly the logic you want to define, is totally totally up to you. Yeah. So that's basically the high-level look at basically how you get all the different pieces of the XCM abstractions working together. And really, at the end of the day, basically, if you can provide to us benchmarks which will satisfy this XCM weight info, we will go ahead and generate for you all the things needed to get all of XCM working. And this is kind of what we think is a pretty good story, given how abstract and how configurable XCM can be. And so some of the future steps I think we should think about, probably we should do another presentation in the future based on fees and payments. That's something I didn't really cover much, and something that we're actually still discussing still. Also another presentation on unit tests and integration testing. Again, another piece of this retreat that we weren't able to cover here in this presentation. We definitely want to get user feedback from all of you and iterate on the benchmarking pipeline. So I've been designing things to get things working for StateMine, Kusama, Westmint, all that kind of stuff. It could be that as soon as you start doing scenarios for your chain, you say, hey, I want X and Y feature. Definitely let us know. We can definitely talk about it and implement those features into the benchmarking pipeline. We also want to create a bunch of tools to test throughput and performance in XCM. So probably, once we have all this benchmarking and weights in, we want to make sure that if we fill an XCM queue with a ton of heavy messages, that everything is being processed in time. So these are probably some tools we're going to be developing and things that you'll be able to take advantage in any of your test networks or local networks. Of course, we want to complete an audit of XCM, and then I guess eventually want to ship it to Polkadot. So that's my presentation. Hopefully I didn't talk too fast. If so, you can always watch back on half speed. Other than that, I think we're going to answer questions from the community, both of us. Please populate the questions in the crowdcast, and of course we can also answer the questions in the HackMD for the meantime. And I will let Gav talk. I think he had a few questions already answered in the
Yeah, thanks Shawn and Gav for the presentations, both of you. It's been super interesting. We do have a couple of questions from the Cloudcast directly. I've been going through the questions on the HackMD, and I think most of them have been answered. So I suggest we go through the questions that we have in here. And one of the first questions that popped up is about Spree or Spree. I don't even know how to pronounce that correctly. The question is, more or less, if you have an estimation of when Spree will be ready, and how does it fit with everything that we discussed so far today? Let me unmute you, Gav. 1 minute.
Sorry, am I on?
Yep, there you
go. Spree is, I don't want to give any concrete dates for Spree because I think that would be disingenuous, but it's probably the biggest single feature that is planned for Polkadot 1. So basically Spree would be the final piece of core functionality of the Polkadot 1 series, and after that it's going to be Polkadot 2, which will be much more much bigger alteration.
Okay.
It's going to happen after Parathreads and after the XCMP optimizations. So it's it's pretty it's basically the third of 3 things that we want to achieve following the initial Parachains launch. So don't expect it particularly soon. Certainly don't expect it until after Parathreads are a thing. And it doesn't really change much that we're talking about here. It's essentially mostly an optimization thing. You can achieve everything with Spree sorry, you can achieve everything with having a separate chain that you can achieve with Spree. Like the whole point of Spree is to provide a trusted location that can receive and send messages and does some particular logic. The key thing about Spree that makes it cool is that this trusted location is sharded and is guaranteed to be the same logic across multiple chains. So you can kind of do stuff like transferring assets. As long as the transfer happens from within the Spree bits of logic, then the chains don't actually need to trust each other. They only trust their Spree compartments. In the same way that at the moment, if you want to achieve that, you do it through a reserve chain like state mine or whatever, where you can be reasonably sure that the logic is going to be executed correctly and can't be upgraded into something that is going to let your expectations down. Yeah, I think that's
perfect. And you mentioned parathreads in your answer right now. And one of the questions that the community has been asking a lot is this ability of parachains communicating via XCM messages through XCMP with parathreads, right? Will that be possible?
Oh yeah, of course. Like parathreads achieve everything that parachains provide. The main difference is like scheduling. And so there are some caveats for message passing to threads. The main two caveats are channel setup between between threads is going to be something that you actually have to pay for. With chains, it's reasonable to expect all parachains will just be able to have free channels to all of the parachains because there aren't going to be that many of them. With parathreads, there could be like potentially tens of thousands of them, and they can't all just have free connection with each other. So it's going to cost money to set up the buffers and so on. The other thing is that they must, parathreads can in theory not be pinged for some time. In principle, they could go days between being woken up. It's pretty important that if they have anything in their queues, any XCM messages to be executed, that they actually get pinged in a relatively timely fashion. A few hours is reasonable, more than a day, not so much. So if it's going to be a parathread that you're expecting is going to need to send and receive messages, you kind of need to write your logic so that there's a guarantee that it's going to wake up at least once or twice a day. And that's like more of an economic question for the parathread designer. Otherwise the messages will just get silently dropped. That's the sort of downside with parathreads. Yeah,
makes sense. Makes a lot of sense. And then the other thing that has been asked, and you talked about this common good chains, you mentioned state mine, if I'm not mistaken, is how will state mine chain validate these transfers for bridge parachains, right? Should parachains notify state mine chains on every deposit or withdrawal? How would that work?
Parachains.
Like the communication between state mine and parachains in this case, I think it's the question.
Can I read this question somewhere?
Of course, it's like all the way down, third to last.
All the way down, third to last. Is there a link?
No, I'm sorry, but I can just paste it here in the chat.
Yeah, do that.
There you go.
It transfers for bridge parachains. I really don't know. I can't pass this question. I'm not actually sure what it's asking.
All right, no worries. I mean, maybe I'm just looking who asked it. All right, the Caribbean team. If you could like rephrase the question and we can go over it again, I very much appreciate it. But yeah, and then the other question that I wanted to go over here is looking at the next steps that you went over, Gav, in the presentation. You talked about query response and success. And the question that Jack from HydraDX was asking is if that will be based off finalized blocks or what's the idea behind it?
If that would, sorry, repeat that? I didn't quite hear.
Yeah. So the question is, will the query response and success be based off finalized blocks?
Query response. No, it has nothing to do with finalized blocks. This is not an off-chain thing. This is entirely on-chain. So the idea is that a message gets sent somewhere, like transfer me a balance, and then at the end of that message, depending on whether it's successful or a failure, it sends another message back to the sender saying, hey, I transferred it, or hey, I didn't transfer it. So it's very, very simple. It's just doubling up the XCM message, which means it's going to take, however long it took to get there, it's probably going to take about the same amount of time back. It's going to be dependent on queue size. There's nothing special going on. It's basically just the receiver is going to send a message back to the sender.
Okay. And then going back to XCM, as the question on order, Hank from Tala was asking, when a parachain receives two messages from different parachains, what's the order to process them?
There is a queue, and it processes according to the queue. So basically, the messages come in. They tend to get queued in a random fashion. So for an XCMP queue, it actually looks at the incoming queues, kind of picks a random point, and then just kind of goes on from there. Actually, it does a shuffle, so it just picks a random selection and queues each one accordingly. That's probably not going to change in the near future, unless we end up, unless there's something significantly problematic.
All right. Makes sense. And then going to benchmarking weights that you Shawn covered. The question that we're having here is, how should we think about the unit of weight? Since the currency being sent is not usually the native currency anymore. Thus, perhaps a price oracle is needed. Would love to hear your guys' thought on that. That's the question. This is something that we're considering for StateMine, Statement. Where price oracle will be kind of sensible. At the moment, we're kind of using the existential deposit as a kind of makeshift price oracle, assuming that the existential deposit will be approximately the same kind of thing for each of the currencies that support an ED. It has to go through the governance, so it's not something that you can trivially game. And then, essentially the amount of EDs that is the fee in KSM or DOT or whatever, where you would just take that number and multiply it by the ED of the other asset that you want to pay fees in. Maybe add a little bit because there's a possibility that it could be a bit below or whatever, and then sorted. Pay the fees accordingly.
Yeah.
All right.
Even in the future, we could have parachains. Sorry, is there an echo in this?
Yeah, I just muted Gav.
Okay. Yeah. In the future, we have parachains themselves, which act as like a starting point. So this parachain could have lots of different assets, right? Act as basically like a DEX. You forward your transaction that you want through this parachain. It does the swapping in whatever fees that it knows that the other parachain can handle, and then relays the messages onto the next parachain, right? So this kind of a future spot for a parachain could definitely help make the whole ecosystem very friendly to lots of different fees and payment types.
All right. And I've got one last question here regarding versioning. I hope I read this right because it has a lot of versions and whatnot. But if not, it's the last question on Ask a Question here, Gav. It says, so it sounds like there are two upgrades to fully get on XCM V1. First, upgrade to 0.9.10 and the V1 API using V0 messages on the wire. Then, when all chains we want to interact with around 0.9.10, hopefully for weeks, there's another upgrade to switch to sending V1 messages over the wire. Is that correct?
That is correct. So there's actually three one I didn't mention. The first one is upgrade everything to V099. This is because V099 contains a fix that makes V0 messages be possible to send. If you look at the Pala XCM, it's got like it's got a couple of dispatches that allow you to send XCM messages. These prior to V099 it was not possible to translate these V0 messages into V1 messages, just one of the features that we removed in V1. And that means that it's really important everyone moves from V098 and below into V099 as soon as possible. Once people move to V099, and this is API compatible, nothing needed other than a cargo update, then everything's kind of ready for people to upgrade a bit more leisurely to V0.9.10. Then as people upgrade to V0.9.10, people can start moving their code bases over to the V1 format, the V1 API. The V1 API is quite a lot nicer than the V0 API. There's a lot of like things that we fixed that make certain mistakes less likely to happen. So definitely recommend moving to the V1 API anyway. And then as people move over to the V1 API and deploy these chains, we can, well, basically as chains move over to the V0, 9, 10, they will understand V1 messages as they're sent. So hopefully 4 weeks, and then we can actually have V1 messages on the wire. People can move over to the V1 API a bit more leisurely. They don't have to use V1 for authoring their messages until we remove the V0, which we're not planning on doing anytime soon. It's probably going to be there for another few months yet. So it's mostly, the big thing is to get firstly to V099 as soon as possible, really as soon as possible, and then V0910 hopefully within 4 weeks after it's released, so that we can use the V1 on the wire.
Okay, perfect. All right, I think that was like very well timed on the hour mark. So thank you very much for that. And yes, I'll just close it here. Thank you guys a lot for your time. Thank you everybody for joining and asking your questions. I think there's a lot of this coming in the future, so we'll be continuing talking about this a lot. But anyways, this is a very good starting point. And again, thank you very much for making the time and for walking us through what you've been working on the last 2 weeks. Probably a bit more time, but specifically on the last sprint that you did there in Stockholm. And again, thanks, and hope you have a very good day.
Great, likewise. Thank you for tuning in, everyone. Cheers.
Bye-bye. The question is how I end this.